Welcome to the sports performance session. My name's Craig Twist. I'll be chairing the session. Sessions are 5 minutes, 5 slides, and then we've got 4 minutes for questions. So, okay, our final talk this morning is Stefan. For those that are late to the room, the final talk, the speaker is withdrawn, so we'll be finishing after this session. Stefan, all yours.
Mr. Chairman, dear colleagues, I'll be talking about a study which my colleagues and I have been working on for the last few months, entitled Physical Fitness Assessment of Young Artistic Gymnasts. And artistic gymnastics is a wonderful sport which can be practiced from a very young age. And also, optimal health and level of physical fitness are both essential for all gymnasts in order to efficiently and accurately perform different skills and routines. And at the beginning of this year, my colleagues and I won a project entitled Physical Fitness Development in Bulgarian Artistic Gymnasts, which was also funded by the Academy. And the aim of this particular study that I'm presenting today was to assess the physical fitness of artistic gymnasts and also to show the impact of the training on the gymnast's health. And you can see on the map the areas, the different regions in my country where we went to collect data. And 131 gymnasts in total took part in this study. They were between the ages of 5 and 16. And in order to assess and evaluate the health-related physical fitness, we applied the AlphaFit test battery, which consists of different anthropometric measurements and different tests, and they're all listed on the slide. And very briefly, we measured weight, height, waist circumference, and 2 skin folds, triceps and subscapular. The body mass index, waist to height ratio, and percentage of body fat were also calculated. The percentage of body fat was calculated based on the 2 skin folds, triceps and subscapular, by using the Slaughter's equations, which are predominantly used in children and adolescents around the world. Also, we applied 2 specialized softwares, WH Andrew Plus, provided by the World Health Organization, in order to compute the percentile scores for height, weight, and body mass index, as well as a modification of our own software, which was created last year as part of my PhD dissertation, and it was called Beep Shuttle Junior. This software administers a 20-meter shuttle run test, calculates the predicted VO2 max, and also computes the percentile score for each individual based on international criteria and norms. For the other tests, we calculated the percentile scores based on European international norms in order to evaluate the results of each participant. Going to the results section, the body mass index assessment suggested that 12 of the gymnasts were overweight and 3 were obese. However, you can see on the right side that gymnasts showed substantially lower amount of body fat. The percentile score was 16.8, which was significantly lower than the 50th percentile of European children and adolescents. And you can see that only 1 gymnast was actually overweight and 2 obese. And on the next slide, you can see the results of the other tests. And firstly, it was quite interesting for us to see in the left corner, the percentile scores of the hand grip strength test show that gymnasts had lower hand grip strength test in comparison to their peers. But this is the case because gymnasts on average have smaller body size, and also because the hand grip strength test shows only the absolute strength, while the standing long jump test, for example, it involves the relative strength as well. And therefore, we try to find relative percentile scores for the hand grip strength test in the literature in order to appropriately assess the results, but we couldn't find them, so future research should establish such norms in order to appropriately assess the results of gymnasts and similar populations. And on the percentile scores for the standing long jump test, 4x10-meter shuttle run test, and the maximum oxygen uptake were significantly higher than the 50th percentile of the European international norms. And in conclusion, artistic gymnastics improves the components of physical fitness and positively influences children's physical development. And although practicing an anaerobic sport, gymnasts had better physical fitness, including higher aerobic capacity, and the percentage of body fat should be used instead of the body mass index in order to appropriately assess the weight of the gymnasts. Thank you very much for your attention. I can take any questions you may have.
Thank you, Stefan. Questions from the audience, please? Okay, I'll start with a question, Stefan. Can you just explain to me your reason for this modified multi-stage fitness test? So, is it a 10-metre test? What was your reason from changing that from the original 20-metre version?
Yes, the original one is the 20-metre shuttle-run test. We modified it and we changed it to the 10-metre shuttle-run test in order to make it easier for gymnastics coaches to make the assessment in the gymnastic facilities, because very rarely we can have 20 meters in a gymnastics hall, and also because a similar test is part of the Bulgarian test system, which assesses aerobic fitness. So we try to modify the Bulgarian system as well and to provide a better way to give a score of the aerobic fitness of the gymnasts. And also by applying this 10-meter shuttle-run test, we can get a better score, not just shuttles, but also predicted VO2 max, predicted maximum oxygen uptake, and a percentile score of this VO2 max, which is based on international criteria, so you can see exactly where your gymnasts are in comparison to international norms.
Are the running speeds on your 10-metre test the same as the 20-metre test?
The running speed starts from 8.5 kilometers per hour and increases with 0.5 every 1 minute. They are the same.
Okay, so I'm just thinking this through. Then, if you're running at the same speed but over a shorter distance, there's going to be a greater neuromuscular load when you're shuttling backwards and forwards. And if you look at some of the work that's out there at the moment, would suggest that you wouldn't cover the same. It's actually quite more difficult to do that. So, is there any validation that you're getting a similar VO2 max reading using the 10 versus the 20 metre?
We did actually a validation of the test. It's an ongoing process. These are the preliminary results, but we did the validation of the 20-meter shuttle-run test. Our software, the original one was for the 20-meter shuttle-run test. We did the modification for the 10-meter shuttle-run test. We did the validation, and the main score, the average score, the average scores didn't. There was no significant difference between the average score. But the other thing is that the correlation wasn't so great, so we need to work on this. And you've got the point that they might be not
I think they'd
so accurate.
Yeah. Okay. Any more questions from the audience, please? Yeah.
Following on that, Craig, did you look at the reliability of that test as well in that group? Because I know from experience testing kids, it can be quite hard. I just wonder whether you done retest reliability as well.
We did that, yes, we did look at that. And it was quite good reliability actually of the test. And also the 20-meter shuttle test, there are lots of body of evidence out there that it has a high reliability of the test. But as I said, the 10-meter shuttle test is some kind of modification which it doesn't have much data on it. So it should be work on it.
Okay. We've got time for one more question if there's one. Okay, we'll leave it there. Thank you, Stefan. Thank you very much.
Thank you.
Thank you everybody for getting here this morning. It was harder for some, I think, than others. But thank you very much. I hope you've enjoyed that. And I hope you enjoy the rest of the conference. Thank you to our speakers as well. Thank you.